Thank you, Michael. Thank you to the Advanced Civilization Lab and UITS ultimately for hosting us here today. Good morning, good afternoon, and good evening to everyone who is watching on the Google Hangouts. This will also be recorded for future watching. It's wonderful to have about 30 people here in the room. Most of them are in class IVMOOC students, which are going to present their project here. There are 4 teams which are going to present. Each team gets 10 to 15 minutes plus 5-minute discussion. I'm going to hold up hands after the 15 minutes are done. And I'm looking forward to these presentations. We have this wonderful display wall here. And it's actually a challenge to use so many pixels. And I believe the different teams have very different ideas on how to make that work on such a big wall. So I would like to have the first team come up and bring up their slides and start the presentation. Thank you all for joining us here today. For those on the Hangout, you can ask questions. And during the 5-minute Q&A, we will also try to make your questions heard and answered. Thank you all.
Hi everyone. So this is Team Cobra. Cobra meaning Comic Leadership Archive, and we'll be visualizing uh, this. Just to give you a recap, this is our team, our client, Dr. John Walsh, who is a professor at the Information Science Department, and of course, mentor Dr. Kati Borner, and uh, yes, great. Yeah, so this is our team, Anirudh, myself, Brittany, Jay, and Shamali. So just starting with the requirement that we got, what Dr. John Walsh wanted was he had a comic book archive. He's collected data from 1963 to 72 and given us the data. And what he wanted was he wanted to study the fandom, comic book fans' information. So what in general he wanted to document Marvel comic book readership and fandom. So our goal was to extract and portray meaningful insights for comic book fan materials. And so what we did is we went by 3 different approaches. So we first established a hierarchy of data contributors by their location. So that's one visualization we have. The second is that we place data across timeline. So that's one visualization. And the third is we group contributors by their gender and location. So the general idea was to study the readership of 2 comic books, Fantastic Four and Avengers, from the period that the specified period that we had data from. Just the next. So related work, we did have an existing visualization called Time Mapper. So it's a geospatial visualization where uh, the letters written by comic fans were visualized. Then we had some books for reference. Supergraphic was one of them, and some websites which used comic book colors. So that helped us learn on color science on how colors work in comic books. So these are just the reference materials. So we want to show the visualization, so we'll just quickly run through the presentation. So simple stats that will be continued by Anand.
So the fan mails that we received were from the period 1961 to 73, and we received over 3,000 fan mails in total. These are some of the stats about number of authors, male and female, and we have collected the data at least from 25 countries, and out of which 92% are from US. And this is the simple metadata. So in the data analysis part, first we had to clean the data and we had to determine the gender so that it will be helpful for our gender visualization. And we also had to fill in some geographic information such as some of the missing states and countries. and also some of the start dates, such as the date of issue, and then we finally check for the accuracy manually. So next we'll look at the visualizations one by one. Can you go to the first link? So we created a web page of our Cobra project, and we'll start with the three visualizations, with Gizmo being the first, and Shama will go through the Gizmo visualization.
So Gizmo stands for Geo Info via Zoomable Map Organization. So that's what we decided. The Avengers is represented with red color and Fantastic Four is represented with blue color. So in this particular visualization, we have followed a hierarchy where you start with the country, the state, city, author, and some information about the author. Now let's take a look at Bloomington and what authors do we have over in Bloomington in the US. So that's Indiana. Bloomington is over there. So we have someone from IO in this visualization. Now we also had George R. R. Martin in our data. So he lived in New Jersey. So yeah, Payon, and that George R. R. Martin. He was he was a pretty active fan wherein he wrote quite quite like two letters for Fantastic Four and one for Avengers. So that was Gizmo.
Okay, this visualization is one of our static visualizations called Art or Author Record Timeline. What we did was we made two separate graphs in Tableau and then combined them and added a timeline. The right side is for the different kind of contributors, so fan club members, contest entrants, and letter authors, and on the left side has the different pages that were commented where you find the letters. So Fantastic Four page, Marvel and Bulletin, things like that. So we see that there's a big increase in the letter numbers after the Mary Marvel Merchant Society was formed. And then after it was absorbed by the Marvel Mania International, there's a huge decrease in letters, and we think maybe that's related. That was the main insight we gained from that. And then it's also important to see that the Avengers was created after the Fantastic Four, so the earlier records are just from the Fantastic Four comics.
Okay, this is our last one. It shows the gender information across the United States. We only use data from the United States because 92% of our data is from there. Some country doesn't even have states, and we have limited time to compare the data of all other four countries. Um, so in our data set, we have four kinds of gender: male, female, and male and female, and unknown. Male and female is the two contributors who wrote the same letters and mentioned their name, like Mr. and Mrs. someone. And unknown people is like someone who say their name as initials or um, we use gender API to find their gender, and the software says someone's name is just unisex, or someone's name says they cannot know the gender, and there's like group of people who said they themselves like student of Bethany College, or and there's some who never mentioned their name. Um, so in the first graph, we the y- y-axis shows the number of reports and x-axis shows the each state of United States. And we ordered this graph by the number. And in the second graph, it shows the proportion of unknown contributors of each state. So the highest percentage is about 8%. Um, yeah, and we reordered the state by according to the first graph. So from this visualization, you can first find most of the gender is male, and um, the majority of our data are from um, New York, California, and Illinois. Um, and if when we first compared these two graphs, we thought maybe we cannot say that there is like strong relationship between these two graphs, but we can say some states have um, a lot of contributors. The percentage of unknown people are lower, and some states have less contributors, have slightly higher percentage of unknown people.
So those were the three different visualizations we had. So the first one, as you saw, was the dynamic one, and the other two were static ones. We used d3.js for this one. Uh, Data documents is an open source JavaScript library. The uh, second and third were developed in Tableau using Tableau. So that's a reporting tool for data visualizations. So that's it. That's our these are our visualizations. So we're open for questions. The file that we got from Dr. John Walsh was an Excel sheet file. So we for this one, what we did was we converted the Excel to JSON and again JSON to represent this data, and we put forward this in front of him that do you want to have do you want to have an Excel sheet where you just put in or add in data later and it gets dynamically represented, or do you want an option that will give you the script and you just run it and the Excel is converted to JSON? So he was fine with both, but we chose that he should get a simpler way to like add data in the future. So now on, it's just that he needs to add the file in the data sheet. The code will convert that dynamically into JSON and represent that on during runtime. So we thought that was easier for him to add first. So scale by based on scaling purposes. That was any other questions.
But then what can you tell about the availability of some of the software artifacts you used? Because ultimately there might be other repositories of letter fans which are much more extensive.
The layout that this one is this is called circle packed hierarchy layout. So this is another option, and for now this worked well for the number of records that we have, And if in the future we want to, I mean, data increases or we scale it, there's another layout that we have, which is the tree map view. So the tree map view is just opening of hierarchy one after the other, and so that's one option that we have. So I mean, for the number of records that we had, I think this looks fine. Yeah.
Hello, good morning, and thank you all for coming. For a little over a month now, we've been working on this presentation with our client Thomson Reuters. Our topic is they had given us like publication data from Ebola on three different types of diseases: Ebola, avian flu, and swine flu. And we had to like find out the analysis on the authors and the collaborations between them and the trend analysis. I'd like to introduce my team member. We have Soumya, Kyle, uh, uh, Manish, and Shravan. And I'm Oliver, and I just had a client as Thomson Reuters. Yeah, so we had specific goals, and we basically like split up into four just for convenience and to bring about like better visual analysis. So our first goal was to identify the authors and the organizations conducting the research. The next one was to find the collaboration between researchers, between organizations, and between the organizations themselves and across organizations, and also the disciplines that collaborate the most. The next one will be the trend analysis on the outbreak of the diseases, and we can see like how the publication data varies, especially when an outbreak of disease happens or like spreading. Let's say there's an academic, there's a outbreak across the country or a specific region. You can see like the publication data in the various countries like increases a lot. So I'd like to continue now with Soumya.
Okay. Before I talk about the visualizations a little bit, since the first thing I'd like to mention that was unique about our project was that we had so many tasks to accomplish. It was not a singular data which you can visualize in multiple ways. It's more like we have so many different tables with so many about thousands of records, which if you join went over 100,000s. So and there were clearly defined distinct tasks. So it was not it was the best idea to kind of create specific visualization for each of those tasks. There was so much we could accomplish in terms of how we can do it. So what we try to do is we try to keep a static visualization, a dynamic visualization, and an animation to explore all the possibilities that we can. So we'll now go about each of the visualizations and we'll talk about it a little bit. This first one is very interesting. One of the goals was to identify the prominent authors and organizations. This specific one talks about the prominent authors who have published a lot of data. So this is just a bipartite graph. As you can see, we have eight Ebola and swine, and here we have listed out the authors who have the maximum number of publications. Like when you see when Kyle hovers on it, we see that this particular person has how many publications going on. And one of the interesting facts to note was almost every prominent author had multiple publications. I mean, multiple diseases publication. It was not like, okay, this person is only publishing in Ebola, which makes sense because if a person is an expert in some field, they always do research on the related field as well. If you can just move up the pointer from any other, you can see that Ebola is very recent, so there's not much publication or research activity going on. Swine and avian have been comparable, but if Kyle can switch to the organization bipartite, we could. Yeah, so here we see there's a lot of swine activity, which kind of makes sense because when Shravan will take you through the outbreak data, we'll see that a lot of deaths happen due to swine. So it's very obvious that most of the efforts were directed towards swine. Another interesting fact to see was if you can see the names of the universities, you can see Imperial College London on the third one. Then you see Taiwan University, you have Canada, and so it means that the publication efforts were spread throughout geographically. And one more statistics to note is that most of the universities are US universities, which is again not a very surprising fact. I think US has a huge amount of funding going on. This was just the basic graph that we captured. One of the other requirements was, what if someone wants to know for a particular disease, which author is the most prominent? So we have static bar graphs for that. If you can switch to the presentation. If we, if we look at this particular slide, we have the next one. Yeah, so we have, that one was an overall data and analysis. This is relevant to each of those diseases, just in case our client wants it. So like I said, we have tried to keep all the options open, like dynamic and static, different levels of granularity. So this was about one of the tasks. The next task would be taken over by Manish. So,
Okay, good morning, everyone. The Omaba task involves design collaboration and disciplines. So the image to your left, we derive visualization using Bluvian algorithms to determine communities or various communities of our data sets. So as you can see towards the left, we have the orange nodes, which and which we can see the most of the disciplines are related to each other. We have computer science theory methods, we have computer science, disciplinary applications, artificial intelligence, information systems. So those are all related to each other. So they will form into one community. And the edges in these nodes represent the amount of times the two disciplines have collaborated with each other. And the size represents the number of times a particular discipline has occurred in our data set. So that gives a good insight into the data set that we understand that public, environmental, and occupational health, although it has occurred a lot of times in our data set, it hasn't been collaborating with other disciplines. However, if you look at immunology and medicine research and experimental, or immunology and infectious diseases, they have collaborated a lot, but they haven't occurred significant amount of times in our data set. So that gives us good insight into how our data is in our publications. And another task for us was to identify, can you just go back on the slide? Yep, thank you. So in our data set, we had a total of 26,006 unique publications, and of which we had 39% of the publications which were multidisciplinary, and the other ones were singular disciplinary research activities. And if you could just switch over to the, sorry. All right, so this graph here represents the percentage of multidisciplinary activities of those 39%. So as we can see here, the most significant collaborations occur between immunology, medicine, research, and experimental, which was pretty evident in the graph to your left as well. And in overall, we can say that most of the multidisciplinary collaborations were too insignificant to have in this graph. And as you can see, as I said, the singular disciplinary research activity is 61%, which was the majority of yes. I'll let Kyle go over.
So next we are going to see about the co-authorship network. So this is basically the collaboration between researchers within the organization for the three diseases. So the size of the node represents the number of publications the particular author has done, and the edges, the thickness of the edges, like represents like the collaboration among the authors. So from this, it is evident that this particular author has like most number of publications, and he has collaborated the most from previous software, which Tamia, like you could have seen that also has published like more in wine and avian. So this is like a network like which shows and this particular network was made from the data from 2008 to 2014, and the trend analysis will be carried out by Shravan.
Thank you. Okay, this is a final presentation, sorry, final visualization. I'll quickly explain you the setting of this visualization. So if you look at your y-axis, you will see the publication count, and that is relevant only to 3 of the lines that you would see. And for the other 3 lines, the y-axis will act as the outbreak count. And when we say outbreak count, we mean the number of people who were affected by that particular disease. And intuitively on the x-axis, you can see here. Now, for three of the disease lines, you will see that the thickness does increase over time, and here thickness represents the number of people who died because of uh, this particular disease. In terms of trend, the first obvious trend that we see is every time there is a peak in disease, you will see corresponding peak in consecutive years for publication. So let's take an example, that is swine. You can see about 1.5, close to 1.5 million people have been affected, and the corresponding swine population is here. You can see the next couple of years, the publication count has increased. Similarly, with Ebola, saw in 2013 a relevant outbreak, and the publication count has increased. Another trend that in this graph is for avian. Avian flu has been appearing quite frequently, and also the research has been very frequent in avian influenza. We may attribute that because they had relevant research over the years, they were able to contain the disease very well, which is again not true for swine population, because they only had one relevant outbreak, and in spite of having a lot of publications, they could not contain the disease. Now we also have a dynamic visualization of the same, so let's have that. Okay, the setting is very similar to what we saw in the static visualization. Now we can look up. It begins from 1996, and the world is a pretty safe place right now. There is no outbreak, and you can see publication for avian and swine has been steady so far. We need to wait until 2006 to see the first outbreak, which will be for avian influenza. So look for the green dot. You can see the green dot is increasing now. And when we come to 2009, you'll see a swine flu will just shoot up because, as I said earlier, 1.5 million people were affected. Look at that, 2009, the bubble just increases. Immediately, you can see that swine publication has increased in size in corresponding years. Finally, we come to 2013. Now you will see the Ebola circle that will increase in size. Blue, you just saw that. Okay, and in the end, you can see that Ebola publication has also increased, which is the red circle. So this was our last visualization. Now I pass to Soumya for the conclusion.
Well, there's no formal conclusion going on, but we just wanted to thank Daddy for this amazing opportunity and activities as well. And one thing we would like to mention is that there was so much we could do. We had so many amazing ideas, and we know there's always scope for improvement. So we would love to hear your suggestions and questions at the end of the presentation. But we just did the best that we could, and we tried to include static, dynamic, animated, and accomplish all the tasks at least one level of granularity or things like that. So, and also I loved my working with my team and made some good friends, and hope you all did too. So thank you. If you have any questions, shoot at us and we'll try to answer.
So did you see any differences in the delay in how the research community is responding to major outbreaks of these three diseases? Like, did you have a chance, in addition to everything else you did, to actually check what delays exist in that system?
We did not particularly see how it affected, but if you look at the larger picture as a generalization, it looks like immediately next year there is an increase in publication, especially in terms of immunology and virology, which we believe is for curing the disease.
The Gapminder-like visualization, you had all these bubbles basically go forward as time progresses, and they're all on top of each other, and it's hard to not have them do that. One trick that might help is to have them basically make a trail, to paint a trail, just like you do it for hurricanes. Kind of they touch down, they make this strange trajectory, and that's basically the pathway of destructions in the case of hurricanes or tornadoes. Here, I think it would be interesting to also capture the size of these circles. And then, of course, they would be again on top of each other. So that creates a nice visualization challenge right there. And you might like to spread out the y-axis more or do some different coding of the data. But I think it was nice to see them over time. So thanks for showing that as well.
Thank you very much.
Okay, good morning, everybody. And this is our group project. It's talk about the field museum collections database visualizations. And our client is the Field Museum of the National History Technology Department. We got a couple of times this month with Shen and Kate, I think. And in our group, we have 5, Richard, Kartik, Jinsha, Joshen, and me. We named our planned visualization as IVMOOC Museum Object Database Activity. And IVMOOC is electronic museum management system. Field museum uses it to manage their collection. This is our visualization goals. We want to show the database activity in our visualizations, and we want to show the movement of the change in the database. For the field museum, their manager can see what they are doing from our visualization, and they also can show that to the public. Most of things we do is we focus on to finding the metadata activity, not only the collections in the database.
So she was saying that it was about metadata, and I think when we started this project, we expected it to be part of the trend in museums, which is visualizing their collections in some manner or form. And there's actually platforms and packages out there to do that. Instead, they wanted us to visualize their database metadata. So in other words, audit records, like the kinds of activity that was going on in their database. So its inception, it wasn't really related to anything in the museum at all. And we eventually kind of brought it back to some of the collection items. But it was sort of very abstract at first because it was just audit records, like a user changed this file, a user deleted this file, and that kind of thing. So a very unusual project, really, if you think about it. So there isn't a lot there. I've looked around quite a bit on this kind of metadata or data about your data, right? It's like even another remove. And there's actually very little on this, sort of like managing your audit data as metadata. But it seems like a very good idea. And I'm thinking the people at the Field Museum, kind of might be onto something, because there's lots to talk about how to manage metadata, creating metadata, how that creates sort of open data standards and that kind of thing, but not this kind of data about the data about the data. So in an article at the Getty on standards for metadata, they talk about how metadata can also be not only about your objects and how you describe them, but also about the context of these objects and how they've been worked over or interacted with in the database by different kinds of users with different kinds of aims and goals. And the IVMOOC system is sort of a modified object relational database. So it doesn't have as strict keys, unique keys between different modules, and that was one of the problems we ran into. Visualizing activity on Wikipedia with chromograms. There was a whole bunch of related work that we found that's tracking changes, or in this case, edits over time. And this is just one of the original ones by some IBM researchers. And this is kind of what we were trying to capture when we were thinking through the visualization. We had to have a time dimension, and we had to be able to account for these different variables in terms of what was happening inside the database. And we also discovered that the staff at the Field Museum didn't tell us about this, that they'd actually had someone else work on this data set, And we did, we don't know exactly what he got, and there's no indication even what year this is. It's just kind of in a bunch of other stuff on the website related to their talking about open standards and that kind of thing with their IVMOOC database. Because it's a public service, they're trying to make all their data available to the public. But a French scholar took what was very similar, seems to be very similar to the data set we had, and we're tracking changes and frequencies of changes and that kind of thing. And instead, he just focused on users and their connections to records. So in red, he's got users, and in blue, he's got records. And it's a Gephi, Force Atlas or something like that. But we were more interested in capturing more variables, the chronology, the time dimension, the frequencies, and also the fields, or what the objects or specimens in the museum collection, how they really intersected with this activity. So we received massive data files originally, CSV files, and the first thing we discovered with the data we got from the Field Museum is they didn't work in Excel or work in numbers. They didn't work in a common database, software package for this kind of thing. We tried to open the original tables, everything crashed. I think we talk about it a little bit more in the slides, but we ended up using Karst, which is a high throughput computing cluster that's brought out up here at UITS. And that was, we mounted our files on there, and we ran data manipulation software, RStudio, which is a server on Karst to do the data processing originally. So these are basically, let's go back just a little bit. So it was basically a data dump of audit records, all related to this China Hall Museum exhibit, which goes on display in June of this year. And to sort of really narrow it down, we got one table for museum objects was 50 plus columns and that kind of thing. But we narrowed down exactly what we were looking at in terms of the audit records. And so we've got unique IDs related to catalog, IRNs. We had users, date, time, tracking changes, the kinds of operations, and the module that it interacted with. So we found 8 separate processes that would be useful to identify the data. And you can see that we've got kind of a low, this was all stuff related to the China Hall exhibit, so it doesn't really encompass their full database. But you can see it's pretty low in the beginning of our period and then spikes in 2014. So we had to sort of think about, okay, what would we really going to try to capture in our visualization? We could look at changes recorded to the IRNs or the objects. We could look at frequency of the changes and a sort of a burst analysis. We could look at total number. We could try to capture the trend of changes over set temporal intervals, or changes by metadata category, which in some cases is module, and then in other cases is department and field, and changes by users, and then of course collection and type. And they have 4 departments and sub-departments at the Field Museum. And then what kind of sample size would you eventually use for the visualization?
Thanks, Richard. All right. Well, 90% of your data analysis is actually preparation. And they sent us actually, after validation, we were sent another file that actually contains the fields. And this really kind of cohered our visualization effort to be more in terms of the department fields, which we have here, ranging from the disciplines of zoology, botany, geology, and anthropology. What we basically decided to do then is get our focus away from users towards more of the items themselves within these fields. So we began looking at them, and these are just sort of summary statistics of what we found in those fields. These were some of our static visualizations that served both as sort of a sample of what we kind of were hoping to get out of our main visualization, as well as a sort of validation process of those. The one on the left is the basic counts of the fields and how that varies. As you can see, anthropology tends to be quite prevalent. And the one on the middle is just the percentages of the relative frequency of those occurring. And the one on the far right are actual themselves, which were far too many to actually list to a legend here. So we just had the counts themselves. What's really interesting about this is that two objects or specimens just sort of persist and have a lot of activity, and then we see there's some slight stuff going on, and then they sort of peter off. And then around 2014, as we expect, they get very active and sort of die around.
So based on the data analysis that we did, we gave our results to the client, and they got back to us indicating that the kind of visualization they were looking for was something similar to what you can see on the screen here. They wanted just the main departments indicated in the visualization instead of the sub-departments. And they were hoping to have a dynamic visualization rather than an interactive one. Even though they did want an interaction that they could stop and start at any point. Part of the reason they asked for a dynamic visualization is because this would be seen not just by the staff members, but also by stakeholders and the patrons of the museum. So a couple of the challenges that we did face was the data wasn't exactly even. You had a lot of activity at a certain point and very little activity at a certain point. Um, One of the problems we had was trying to figure out the or trying to get an even distribution between the burst activities, and the scale of the data set, which was close to, I think, how much was it? Over 50 MB. We finally managed to get that down to around 600 KB, and that was good for us. Yeah, if you can click on the visualization. Hit refresh. No, no, no. No, no. Just use- Yeah. Oh, thank you. One of the things, according to the initial data analysis that you can see, is that there's almost no activity towards the start of the visualization. Even when visualization is there, you can see that it happens in specific months for specific departments. And as you get closer to 2014, you see more and more activity happening with 2014. Like majority of the activity happening in the anthropology department, and like one of the biggest things is, as you see here, anthropology just goes through the roof with its activity. Uh, slides. Yes.
So the plan all along was to do a sample of the top, say, and we ended up, we did a top that kind of basically 100, 120 out of, what was it, 6,000 or something we selected. And it was about 2% of the data set. And there were only 2 departments included in that top sample. So it was only anthropology, which is very active, and then it was, I think, a zoology, insects, or something like this. So then we went down into the data set proportionally to make sure we had all the departments. But I think that in the end, I think our sample size is probably too small. We should add more data, and I think we have plans over this week to triple the size of the sample to increase the sort of activity that we actually see in the animation. And I think that the code we created for this in the workflow is going to make that pretty easy to do.
So, and still we are going to add the function of play and the stop in the animation at the end. And also we are going to add the introduction of each animal so that the users can see which specimen it refers to in the visualization. And
So I think the reason why we focused so much on the processing part of it is really was a high learning curve for all of us, and it was sort of a big data project. In fact, we sent them early analysis of their data, and they said, "Oh, you're teaching us about our data," and they ended up sending us supplemental files with different kinds of variables included, so that we could do some merging and combining to bring things together. So they have a very complicated, like 26 million object database, and they probably don't know everything about what's going on there. So we had to kind of reduce it down so we could get some unique numbers to connect things to actual objects. So we did most of this on Karst, as I said before, in our studio, which is wonderfully offered to every IU person as a server on top of Karst, using a Dippler. Actually don't know how to pronounce that data processing package, which makes it a lot easier. Josh is an expert in SAS, so some of the validation and stuff, but I couldn't solve the frequency counts, relative frequency counts in R, and so he ran that through SAS, and it worked out really well. We used, you want to talk about it?
So one of the things the client requested was to have a website that they could showcase in live in their museum. So we used HTML, CSS, and JavaScript to create the visualization that you saw, and we used the D3 framework to actually visualize the data. One of the things that one of the requests we got from the client was to make this so that it was reusable in the future and it was scalable. So one of the things we set up was a process to convert the CSV data they sent into JSON files that could be then consumed by the D3 visualization that we had created.
That's it. Yeah, this is our group project presentation. So, any questions for us?
Anthropology. Oh. So I'm curious when you saw the jump in activity for anthropology. So that's interaction with the metadata, updating files and so forth.
Basically, it's users interacting with database objects. Yeah.
Got it. Okay. So did you have any insights into what was driving that? Is there actually increased interest in the objects in the museums that those correspond to, or are there new discoveries in the field that might suggest that current information needs to be updated, or any ideas about what was driving that change in activity?
Well, I think in this case, they gave us audit records related to the China Hall exhibit. And I think it's called the Cyrus Tang Permanent China exhibit that's going to go up at the Field Museum in June. So they already sort of answered that question. So what we're seeing is we're seeing activity related to the fact they're getting ready for that exhibit. And clearly, it's an anthropological exhibit. I mean, what was the percentage? It was over 90%, I think, of the activity in that China Hall set was related to anthropology. But I am interested in getting a larger data set from them that would be more. We wouldn't know the answer going into it, and we would get to see a little bit more about. And I think that's what they want in the end, is to see what kinds of departments, what kinds of objects and metadata fields and modules are getting the most activity in general, is what they really want to see.
Got it. Thank you.
Question.
I'm really glad to see you triple the data, even though your deadline basically has passed. So this is not necessarily classwork anymore, but it's really driven by the deep interest of the Field Museum to optimize the internal data management processes and to ultimately have visual interface for museum patrons at the moment in time that new exhibit opens in June. So it's, I think, a unique moment in time that you came in and really helped them understand what's in the data, but also how makes the data more accessible to a much more general audience. And of course, that gives you two user groups. And so I hope you get a chance to, at some point, first of all, visit the Field Museum to actually see the China Hall when it has opened. But second, also, I think there's interest by Kate also to potentially come down and work with you. And hopefully at some point there's also all kinds of reward for you involved, not in terms only of CV items, but potentially also as a place to do major collaborations with. So thanks so much for going for the challenge to take on that data set and wrangling it, and welcome to the real world, because you typically get to do a lot of data cleaning and merging and interlinking and more cleaning and going back to the client, getting new data, more data cleaning, and even more cleaning.
We were pretty shocked when they sent us a whole new file saying, "Oh, we left this column out."
But you went for it, and so I appreciate this. But it's very, very normal. And for me, it's also always interesting to understand how much of the data cleaning should I actually teach, because I could teach 80% of the course about data cleaning, which is appropriate because this is how much you will spend time-wise on each project. But then it's not an information visualization course anymore. But then ultimately you miss that knowledge. So all feedback on this, and I think the student feedback forms, all the students that are registered with you are on it. So please complete those as well. And keep that feedback, because ultimately this is helpful for us to always keep on improving this course. Thank you for presenting. Are there more questions?
This is just a simple question. So I saw there is multiple circles in each section, and how did you sectionize that? I mean, what does it mean?
So each of those circles represents a particular catalog number. So each of those circles represents an IRN. So when some of them get really, really big, we have 1,000 interactions with them. And I think that's why we need to up the size, is because we're dealing with such small entities, so that we need to up the size of the data set. And then we decided to, after talking with the Field Museum staff, to sort them basically chronologically and by field. So those 4 main fields that you saw in there is how we ended up sort of, visualizing them, right? I mean, there are different ways to approach this. You could do it by user and so on and so forth. Or they have something called module, which part of the fact which is related to the modified relational database that they're using. So people are working in these distinct modules that then link up, and it was never quite clear to us how those modules actually linked up. So that's another place to work in the future.
Okay. Hello, everyone. My name is Ian, and these are my teammates. This is John, Vinay, David, and Tianjay. Just give a brief introduction to our project. We were working with retail data. Our client is Dr. Raymond Burke, who's kind enough to be here with us today, so no pressure, right? Basically, we received a lot of data from Dr. Burke. This was mainly in the form of coordinate data, like tracking shoppers through grocery stores, combined with eye tracking. So they would approach a shopper in a store, introduce the project, then they would say have them put on a headset so they could do eye tracking, and then all the data was eventually collected and annotated in the video. Like, so the shopper would annotate the video, and they would basically say, here's where a person stopped, here's what they looked at, here's what they bought, here's what they interacted with, And so, working with that data, we were told to find some insight into it. Our goals weren't quite as well defined as other groups, so we were kind of given a lot of freedom to do some interesting stuff here. We determined pretty early on that Sci2 would not really be an appropriate tool for that, so we had to learn a new tool as well. So this is all produced in Tableau. So we had the challenge of lots and lots and lots of data, with kind of their goal and a brand new tool to learn. I think we did pretty okay. We ended up producing about 4 bite-sized visualizations for you guys, and the goal here is to sort of provide a framework for ways to think about retail shopping data that just hasn't been done before. There is a little research in this field, as far as I understand, especially with this kind of data. So we're kind of going to introduce each of these visualizations to you one by one. We'll go ahead and start with not that. That's the wrong window. We'll start with this one. Here we go. Sorry. Okay. The co-occurrence graph. Pull it up for you.
Sure. So what we're going to have here in a second is a graph that shows a co-occurrence matrix visualization, which shows we've got the sequence ID, which is basically where in the store they are. It's related to the XY coordinates of the shopper. And so on the left, you've got the ID of each one, and then you have the category of the items. The pre-processing for this, we used Excel and went through and normalized the categories, and then went through, took the sequence numbers, ended up with a point at each of the spots where they picked something up, and then went into Photoshop and changed the icons. So for instance, ID number 4, you can see he goes through first. Here, the first thing I pick up is the juice, and then going through the store, and at the end you have a grand total proportional symbol, which shows the total number of items. A couple of insights that we gained from this particular visualization were there's a possibility that when people are picking up more than one thing, there could be a sale or some kind of discount going on. For instance, this person went in, picked up 2 items of pet food, went through the rest of their shopping, went back and got 4 more. So this may show a sale or something like that.
Okay, thank you, John. The next visualization is a static topical bar graph. Might look a little complicated, but it's just a double bar graph visualization. The reason we decided to go with the double bar graph visualization was because of the kind of feedback we received from user testing. So usually we just show them a couple of visualizations that we had, which were dynamic or something like a tree map, and they would just sit, stare at it for 5 minutes, and they'd be like, what is this? So we decided to go with at least one easy visualization. So what this basically does is map the age category and the employment status with the median expenditure and the median actual shopping time. So we had 2 fields, the actual shopping time and the intended shopping time. Intended shopping time was the time that user estimated that they would spend shopping, and the actual shopping time was the time that they actually ended up shopping. We collated these data across different product categories like fish, milk, etc. So the actual shopping time is measured in minutes and the expenditure is measured in dollars. And we went with the median because there were a couple of outliers that were kind of affecting the mean. So we decided to go with the median. From this visualization, you can generally see that
people who spent more time shopping ended up spending more money. So if you ever end up opening a store, make sure that your shoppers spend more time. So it makes sense to have all your milk and essential items right at the back of the store. So they have to walk all the way back. Um, an interesting data point that you can see from this is people who were below 25 and who were employed full-time ended up spending the most money. That is not surprising. They're young, they have money, and they can spend it. Another interesting data point is that people who were retired and who were about 65 ended up spending a lot of money. And again, that is not surprising. They have time and money and they spend it. uh, One surprising point to note here is that people who are under 25 and employed full-time spend a lot less time than the other categories. Speaking relatively, maybe because they know exactly what they want and they can afford it. So they kind of end up spending a lot less time. So I would assume that this particular category is the most possibly attractive for a store owner. One surprising trend that we noticed was that people in the age group between 25 and 34 and who are employed full-time spent the least amount of time and money. This was very surprising to us because usually people in that age group have families, and it is worthwhile to mention that this could be possibly because of the kind of data we had. Not all age groups and employment status categories were well represented. This usually happens. We had kind of around 60 data points for this particular uh, store. So it could be because of that. Uh, I think the rest of the data is kind of like fairly predictable. So it was a couple of interesting trends that we were able to glean from this particular visualization.
Thank you, David. Um, for this project, our main goal is to trying to connect the demographic to the shop behavior. So for this visualization, we extract four different data here. The actual shop time, the intended shop time, the checkout shop time, and also the education level. So for the visualization here, each circle represents one individual, and the different color represents the different education level. And when you mouse over to the for example, the high school or left, it shows all the data related with the customer has the education level as high school or left. And when you mouse over the show trend line, it shows a trend line showing that this type of users, their intent shop time and the actual shop time. So the trend line are more likely to incline to the ground, which means that the users actually they actually shop longer time comparing with what they initially estimate. And from this realization, we speculated that the possible reasons might be some users with the higher education level, they are intend to check the label of the ingredients more than the other level of education, or they may compare with different kind of products. So one potential commercial opportunity for this one is maybe we can develop a mobile application showing more detailed information for the customer who have a higher education. Yeah, this is actually the different education lines here.
Okay. For this particular visualization, we actually thought about what would someone who's managing the store, the inside of the store, would want to see. So we arranged few of the things which make sense and try to find out that this is a correlation between customer satisfaction and the shopping frequency and the actual shopping time, which is categorized by the products that they've shopped for, and the higher category is the gender. The data set actually did not have too many data related to male, so that's what is represented there. It looks like female shop a lot, but it's because of the data. And what you can see from here, this actually helps someone who is managing the store to see which group is more satisfied, what kind of things do people buy more, how many times do they actually shop, and this insight will help them to plan their promotion or campaign because they know everything, what is going on. So we wanted to give something like this. That is all about this particular graph.
Okay, so like I said, we're working with one store for this particular project, the Wyckoff Stop and Shop, which might explain why we've got some skew here because of 60 records. That makes sense. So that's basically it. So it's not. So there we go. Yeah. So that's our project. Do you guys have any questions we can field for you?
So for the fourth visualization, you showed the distribution of customers to shopping times and what they actually bought. Do you envision this going in the future as being somewhat more dynamic and real time?
Can actually be a dynamic thing, which can be directly linked to this thing, shopping management tool or something, where analysts can actually visit and see the whole and plan for the next things, like campaigns or promotions and things like that. This can be dynamic.
I have two questions. So in the scatter plot visualization, it immediately suggested to me that you might also want to look at an analytic models such as regression or general linear model of that type. Did you guys consider doing that at any point? Okay. And another thing that, what would that tell them? It would allow predictions of how much someone would spend of a particular type or category as well. So another thing that you could have looked at, and
we did look into the category specific expenditure kind of thing, but I think that would have been best visualized as a dynamic visualization, and we didn't quite have as much time because, like I said, we did have a lot of pre-maps and stuff that we kind of discarded before we went for this. Yeah, that could have been done, but yeah.
The thing is, for prediction, I think we need more number of data because we just have 52 this thing.
Right, and that raises the question of, like, you kind of have to limit your prediction on the caveats of the data that you were using. So anyway, that actually answered my second question, so I'll get this back.
Just maybe a comment. So I know you had very detailed information on what aisles these shoppers actually walked along, what they looked at, what they potentially also took out, how they potentially also compared it with online or in-store advertisement. So the data is very rich, and you did a number of views of the data. But there are many, many other visualizations that could have been done, but not in the time you had. So I hope that you got interested in this kind of data. I think it's dynamic data, which is now collected in a very comprehensive way, also thanks to the technology which Ray Burke and others have put in place. And I hope some of you will be interested to work more on this project. I think there's a lot of money to be made and hopefully also customer satisfaction to be gained if you do this right. And yes, there are some people which just have 2 kids and they just want the milk, and maybe you want to make it easy on them also, please. But there are also other interests, and you sometimes can serve all of those, or maybe not. Maybe you have to just specialize. This is the store where you go for 1 milk, and this is the store to entertain yourself going shopping, which is a fun activity for girls, at least. I don't know. I was impressed to see how many men actually spend a lot of time in the beauty supplies.
From the last visualization, I think you can make out that men usually don't like to shop, and they shop only when they have to.
Very good. Thank you so much. Let me conclude this. Thank you all for going for this 42 million pixel display wall. I think it's a true challenge. And as you see, some stuff works, some stuff doesn't work. If everybody is down in this corner, it's tricky. I can't even take a photo of this bunch of people. You have to own this place. You have to almost behave like on a theatrical stage. And I think you all will get into environments where you manage people, where you have to own this place. So maybe in a quiet moment of time, try to own it. Just come back, give a presentation on something you care about to others. There are lots of conferences you could hold here. So use this place, not just for class, but for your own purposes. And this camera is about $100. You can also rent it from us or from AVL. So if you want to broadcast yourself, this is an amazing stage you have right here. Thank you all for the class presentations, for the great work, for the good challenging questions and commentaries you have given all of us during this course. I hope you learned a ton. I hope you learned actionable knowledge, and I hope this is helpful for you for gaining summer jobs, for gaining the jobs you really wanted after you're done here at RIU. And I hope to see you around and in some of the other classes that are part of the data science curriculum here at the School of Informatics and Computing, Indiana University. And I hope you have a wonderful summer now. We will go back and grade, and then we will get to hear one more announcement or two when all the grades are done. So we hope to have a beginning of next week, latest end of next week. I think that's also when I want all the grades. So there is a definite deadline. All right, thank you all, and thanks for going for this challenge with the big wall presentation.